Hi everyone, Assalamualaikum. Alright, I made this video to explain how we choose a correct U in video 2.4.2. Alright, hope you understand and enjoy this video. Alright, we look at example 4 in video 2.4.2. Okay, let's say we don't know how to choose the correct U. Okay, let's say we doing the first try. Okay. Alright, from the function tanh x sec cube x. Okay, let's say we want to integrate this function. Okay, and we can list down the possible u that we can choose. Okay, the first one, let's say we choose u equals to x. The second one, let's say we choose u equals to tanh x because tanh x appear in this function. Okay, and then the third one, let's say we choose u equals to sec x, or the fourth one, let's say we choose u equals to sec cube x. Okay, we choose u, we can try choose any u that given in this function. Alright, okay, let's say first try we choose u equals to x. Okay, actually u equals to x is not suitable because this is very simple. This is single x. Okay, alright, for this question, let's say we choose u equals to x, and when we use u substitution, after we choose u, we must differentiate, okay, to find du over dx, and then we need to write dx as a subject. So in this case, our dx equals to du, right? And then when we substitute back, okay, into the given question, now we have integration from ln 2 to ln 3, and then tanh u, okay, since we choose u equals to x, okay, and then sec cube u, and then du, okay. So we substitute from here, right? And then from here, no more variable x. Okay, after we substitute, we success right in terms of u and du. Okay, but in this case, when we compare with table of integral for hyperbolic function, okay, from here, there is no formula for integration of tanh u sec cube u. There is no formula here. Okay, when we check one by one. Okay, so means that there is no appropriate formula to use from the table of integral to integrate hyperbolic function, right? Right, so in this case, we choose the wrong u, okay, because we cannot integrate, yeah, because there is no appropriate formula to integrate this function. Alright, means that we need to choose another function as u. Okay, you got it? Alright, now the same question, okay, but we're doing the second try. Okay, from the given question here, we recall back. We have 4 choice of u. Okay, let's say we choose u equals to x, u equals to tanh x, or maybe u equals to sec x, or maybe u equals to sec cube x. This is the possible u that we can choose since the function is given in this question, right? Right, the first try in the previous slide, we choose u equals to single x, okay, which is not suitable. Okay, so now let me try u equals to tanh x. Okay, since tanh x exists in this question. Okay, alright, so from here, after we choose u, okay, the first thing we must define u, and then now we define u equals to tanh x, and then after that we need to find du over dx. Okay, Why we need to find du over dx? Because when we use u substitution to integrate, we need to write all terms in variable u and du. So to make a symbol du, so we need to differentiate. Yeah. So from here, after we differentiate tan x, so we get du over dx equals to sec squared x. Okay. This is derivative part. Okay. Every time when we use u substitution, okay, we need to integrate and differentiate. Okay. This is derivative part and this is integration part. Okay. That is the idea in u substitution. Okay. Integration using u substitution. Alright. So after we define u and then we differentiate, after that we need to write dx as a subject. So we get du over sec squared x, right? And then from here, our u now equals to tan x, okay? And then after we differentiate, so we get sec squared x, okay? But from the given question, we have sec cube x. So to write in terms of sec squared x, okay, we can split this function into this function. Okay, we have tan x and then we split sec cube x to sec squared x times sec x. Okay, because when we multiply sec squared x and sec x, we get back sec cube x. Okay, why we split to this function? Because when we differentiate tan x, the answer equals to sec squared x. So to create the symbol in sec squared x, we need to split from sec cube x. Okay, so we get this. Alright. And then, now our u is tan x, and then when we differentiate, we have sec squared x here. Okay. And then, when we rewrite in terms of u and du, okay, so we need to replace, okay, we replace u and we replace dx here, okay, we replace tan x and dx, okay. So from here, so we have integration from ln 2 to ln x, we replace tan x equals to u, okay, and then we just replace tan x and dx only. We replace tan x equals to u and we replace dx equals to du over sec squared x. We don't need to replace sec squared and sec x because we can simplify later here. Okay, so after we replace u, okay, and dx here, okay, and then we have this. Okay, after that, we can simplify sec squared x and sec squared x in denominator here. And then after we simplify, we get integration from ln 2 to ln 3 u sec x, okay, du. Okay, so from here, we still have sec x here. Okay, means we can't simplify all variable x. Okay. When we use u substitution, we need to simplify all variable x so that we can write all in terms of variable u and du. Okay? Means in this case, since we can't simplify all variable x, means we make a wrong choice of u. Means that u equals to tan x is not suitable. Right? So we need to choose another function as u. Alright? Got it? Alright, now we still under example 4, but now we're doing third try. Okay, same question. Alright, so from the given function here, okay, we done doing the first try, the second try, now we continue the third try, okay, which is u equals to sec x, okay, and when we use u substitution, we need to define u. So now our u equals to sec x, and after we define u, we need to differentiate, okay, to get symbol du here. Yeah, so when we differentiate sec x, the answer equals to sec x tan x. And after that, when we use u substitution, we need to write the x as a subject. So after we cross multiply here, so we get du over negative sec x tan x. Okay, and then we substitute back. Okay, so now from here, okay, from du over dx equals to negative sec x tan x. So we go back to our question here. So we split to this function, okay, from the original function in the given question here. Alright. So from the given function here, we write sec x tan x at the back, okay, before dx. Okay. So we write sec x tan x at the back, and then to get back the original function in the given question, so we need to write, now we have sec x tan x here. So to get back the original function, we must write sec squared x in front here, so that when we multiply sec squared x and sec x, we get back sec cube x and then tan x here. Okay, why we write in terms of the function when we differentiate? Okay, because we can simplify after we substitute. Alright, so from here, okay, our u equals to sec x. Okay, and then after we differentiate, we get this function. Okay. Okay, after that, we need to replace u and dx only. Okay. Right, so from the given question, our u equals to sec x. Okay. So when we have sec squared x, so we can write u squared. Okay, this function, we no need to replace because we can simplify later. Okay, we just replace u and dx only. Okay, and then we replace dx equals to du over negative sec x tan x. And after we replace, we have the same term containing sec x tan x. That's why we try to differentiate first. And when we differentiate the function that we choose as u, then we have idea to split, okay, into the form of sec x tan x. Okay, so we go back from here. Okay, so from here we can simplify. So after we simplify, so we still have negative sign here, so we can move out. Okay, and then we have u squared and then du. So from here, okay, all terms in terms of u and du, and no more variable x from here. Okay, and also no more hyperbolic function. So we just integrate using power rule. Okay, so in this case, we can integrate this function. Okay, because we success right in terms of variable u and du only, and no variable x. Okay, so means that in this case, we choose the correct u, because after we differentiate and then we substitute and then we simplify, we only have variable u and du. Alright? So from here, you can continue to the next step. You just integrate using power rule. Alright? Got it? Alright, from the previous slide, after we simplify, so we get this. Okay? And then from here, we just integrate with respect to u using power rule. No need to use hyperbolic function because there is no hyperbolic function here. Alright? So this is from video 2.4.2. You can refer it. Okay? So the final answer equals to 0.0987. Okay. Alright, let's say you have no idea how to integrate this function. Okay. So first step, what should you do? Okay. You just change this function into basic hyperbolic function. What is basic hyperbolic function? Basic hyperbolic function means sinh x and cos x. Alright. So we can write tan x equals to sinh x over cos x, and then we can write sec cube x equals to 1 over cos cube x. And after we simplify, we get this. Okay, now we write this function into the form of sinh x and cos x. So if you have no ideas how to integrate this function, you can make a try. Let's say first try, you choose u equals to sinh x. But after differentiate and then after substitute, we cannot simplify. Means u equals to sinh x is not suitable. Okay. And then let's say second try. You choose u equals to cos x. Okay. And after we choose u, we need to differentiate, and then we need to write the x as a subject, and then we need to substitute back. Okay. We just substitute u. Okay. Which is now our u equals to cos x. So we have u to the power of 4. We just replace u and dx only. Okay. We still write sinh x here because we can simplify sinh x from numerator here and denominator here. Then we success write into the form of u and du, no more variable x. Means that now we choose a correct u. Okay, so we can continue our integration. Alright, that's the way how we choose a correct u. Okay, every time when you stuck, you can change to basic basic hyperbolic function. Okay, if this is trigo function, so you can change to basic trigo function. If this is hyperbolic function, so you can change to basic hyperbolic function. Alright, you got it? Faham ke tu? Tak faham boleh tanya ya. Okay, bye. Jumpa lagi.